Before we start this video, if you are new here, then please subscribe to my channel, turn on the notification bell, like this video and share it with those who want to learn analysis and design of RCC structure and steel structure. And if you want to learn AutoCAD 0 to Hero, then buy my ebook AutoCAD Notes to a Beginner. I will put the link in the description box. Enough talking, let's get started. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello civil engineers and welcome to CIVIL53. In this video, we will discuss about analysis and design part. As we know that in AutoCAD 2D software we just do 2D drafting, after that we created the 3D model of the plan. In structure, we know that there are various components like foundation, beams, columns, slabs and stairs. The beam size, column size, reinforcement of beams and columns we decide in Staad Pro software and also in ETABS software. As per loading, we have to analyze and design. If we are going to construct a structure, we know that there will be various loads acting on it, such as life load, dead load, seismic load, wind load, and snow load. We have to assign or apply these loads on the structure and check whether the structure will be safe or not. That is why we have to do analysis and design. Now let's talk about the nature of the loads, artificial loads, and natural loads. Artificial loads such as dead load and life load. First, we will start with dead load. Dead load are static forces that are relatively constant for an extended time. They can be in tension or compression. In short, they are immovable loads. Second, life load. In short, they are variable or movable loads. Now let's talk about the natural loads such as wind load, seismic loads, and snow loads. First, we will start with the wind load. It's primarily horizontal load caused by the movement of air relative to Earth. The nature of the wind load is unpredictable, so we should consider all of these four directions, east, west, north, and south, in the design process. Second natural load, seismic loads. It's also unpredictable loads, so that is why we should consider all of the four directions, east, west, north, and south, in design process. Third, snow load. Snow load is the downward force on a building's roof by the weight of accumulated snow and ice. The roof or the entire structure can fail if the snow load exceeds the weight the building was designed to shoulder. For the load values, we have to refer IS 875 part 1 to part 5. For dead load, use IS 875 part 1. For life load, use IS 875 part 2. For wind load, use IS 875 part 3. For snow load, use IS 875 part 4. For combination load, use IS 875 part 5. Building-wise, dead load and life load varies accordingly, whether it is commercial, public, or residential building. Before you start designing, you should know all of these concepts so that design process will be easy. We know that we have steel structure and RCC structure. We use IS 800 for steel design and we use IS 456 for RCC design. In this Staad Pro software tutorial, we will learn how to design steel structure as well as RCC structure. In the first part, we will start with steel structure such as towers, bridges, trusses, industrial trusses, etc. In the second part, we will design RCC structure. Before we start this Staad Pro tutorial, there are some basic concepts we should know. The long form of RCC is reinforcement cement concrete. Why do we use steel in concrete? Because concrete is weak in tension and strong in compression. In RCC structure, in reinforcement, we provide cover, stirrups, and hooks. Why do we need cover? To prevent from weather conditions effects. Why do we need stirrups? To reduce shear force. Why do we need hooks? To resist seismic movement. This is all about the introduction part. In the next lecture, inshallah, we will start Staad Pro and we will design our first project, which is American Tower.